Agent X11, Hollywood Dark Journalist, begins now.
And welcome to another episode of Agent X11, Hollywood Dark Journalist. My name is Penny L.A. Shepard, and I am Agent X11. I am joined today, and let me just turn on in my style, because I have style. I'm going to display everyone's name so everyone knows who everyone is. We have Joan Renee, my co-host, and Brian M. Bowden, who apparently is now a co-host as well. So I'm going to be putting you in the promo very soon. And we have our guest, Dr. Weeping Yu, and Steven Sanchez. And then also, this is Brian Singh Presents segment. And so we have Brian Singh in the house. Oh my God, it's a baby. It's a baby. It's Crystal.
Here and Brian's going live.
Yeah, I'm gonna have to jump off. I'm about to go
going live now.
We are live.
He is live right now. So we're live from New York City. No, I'm just kidding. Or as Brian likes to say, live from New York City.
New York City, exactly where it is.
New York City. So this is Dr. Yu's universe, and we've created an intro for him, which, you know, it's fun. We like to have fun here. So I'm going to play the intro.
Woo, ooh, it's Dr. Yu. Woo, ooh, it's Dr. Yu. Woo, ooh, it's Dr. Yu. Dr. Yu's universe. Yeah. Spin on a cosmic ride. No up, no down, no left, no right. Dr. Yu's got stars in sight. We welcome you to Dr. Yu's universe, where planets sing and comets dance. Tune into you. He's broadcasting from a cosmic trance. Ooh, it's Dr. Yu. Universe. Welcome to Dr. Yu's universe. Whoa. We all strangers in a strange land. Whoa. In the universe of stars and sand, where everything exists but not. Get ready to shout. Whoa. Ooh, it's Dr. Yu. Ooh, it's Dr. Yu. Yeah. Ooh, it's Dr. Yu. Dr. Yu's universe. Yeah. Nothing is what you thought you'd find. Get ready to adjust your mind. Forget all that you have read. Get maximum room, make space in your head. Welcome to Dr. Yu's universe, where time does not exist. Listen to Dr. Yu. He's phoning in from Earth number 2. Yeah, he's calling from the cosmos just for you.
All right, and we are back, and we are in Dr. Yu's universe. I was talking to Steven offline, and he sent me this little video. Do you want to tell us what this video is, the thunderstorm?
Yeah, sure. Back, I think it was 2023, I was involved with a mathematician named Marco Rodin, and he is really well connected with the people at the Tesla Tech thing, and he's kind of like a standing invitation to come anytime he wants. And he said, well, there's going to be this interesting individual by the name of Malcolm Bindle, and he's going to be demonstrating this stuff called thunderstorm generator from the Strike Foundation. And the reason they explicitly got a hold of me because they know all of my aerospace background on R&D and stuff. So they needed a fabricator at that level to help them basically assemble one of these things literally on site. So we literally converted the back part of the convention center and a couple of the hotel rooms and literally fabricated this thing on the spot. The reason for it is to prove the technology is this simple and to show it without no sleight of hand that this technology actually works. So what we did is I showed up and they brought all the components, but they needed to buy a AC generator because they're going to convert it, and they runs on gasoline. So I was the only one there to have some extra cash. So I ran over to Costco, bought an AC generator, and then we proceeded to tear it apart. So what the whole concept of this thing, the thunderstorm generator, works on the basics and the physics of lightning. You got hot and cold air and hot and cold moisture. And when they go together, they cause a interactive charge between each other, and boom, you get lightning. So it kind of works on the same principle. So in the quick time that we were talking, I kind of drew up a picture of what the actual generator looks like. And I don't know if you can see this. I'll do it this way. So what you see there is this is a sphere, and this is a sphere over here. And then there's a tube inside of a tube. So what this design does, so it can actually take air, or the intake, if you will, comes in here, and it causes it to swirl like a tornado inside the inner tube and runs one direction clockwise. It's called the internal side clockwise, and then comes out. On the other side, it goes counterclockwise on the outside in another tube. So it's a tube within a tube. So a very interesting interaction happens when one force is going one way and the other one's going the other way. As they're passing each other, there's a very interesting transference happens. So they take breathable air and, oxygen. There's a bunch of other rare gases in our air. So it goes into a container, and I'll use this for an example. And it's got one of them bulbs you got from a terrarium for animals and critters. You have that grow bulb, so it has the right bandwidth. So it does a very interesting thing to the air. It energizes some of the rare gases, and it goes down this tube into a thing called a bubbler, and it's just a big long tube with water in it and steel wool, and the steel wool's in there so it can break up the air, and this air is going through the intake of the engine. So the engine's vacuum, if you will, is pulling this air through this unit. And as it pulses through this thing full of steel and water, it causes the little bubbles to expand and collapse, expand and collapse, expand and collapse by the pulse of the engine, and basically turns the air into plasma. Now, as it goes through this device, exhaust is on the outside and the intake's on the inside. So as it comes inside it, it's getting superheated as it's moving in a tornado shape, and the opposite one's going the other way on the outside of it. So there's an interesting transference, thermal coupling going on inside of this device, and it basically energizes the intake of the oxygen. By the time it hits the engine's intake, it's plasma, and that's fuel. You can detonate that. So it goes inside the engine, it detonates, and what do you get when you detonate plasma? It goes right back into oxygen and water. So it was the most darndest thing. We had this thing all set up, and they had one of those things. They use them in Formula One so they can make sure nobody's cheating. It's a gas analyzer. They make sure all the oxygen and stuff like that. So they had, because Malcolm's from, I think he's either from Australia or Europe, but I think he was coming from Europe for the convention. So he had one of these devices that's certified. So it reads all the O2, the oxygen, the hydrocarbons, all that kind of stuff. And they stuck that on the exhaust pipe. They fired that darn thing up, and it just flatlined. There was no hydrocarbons or nothing. And it was interesting because that's when I put it all together with him. When we fired it up, I looked at one of my friends. He's a scientist from Hawaii, and there's this big blue flame coming out of the exhaust pipe. And he goes, "You know what I see?" And he goes, "Yeah, I know what you see. That's pure plasma flame. It's like those plasma torches." So that was really amazing. Then we had some complications, and at the end of the convention, this happened a week. Every day from about 9 o'clock to about 11 o'clock, this was broadcasted all over the world. And it got the attention of Lawrence Livermore Laboratories. And they got a guy over with a mass gas spectrometer, and they hooked that thing up, and we flatlined that one too. And I do have a video of that.
Okay, so I'm going to play the video that you sent me. It's not very long.
Yeah, and that shows you the device. Yep, that's the device right there. That's Malcolm right there at the bottom. My hand holding one of the parts. So we were harvesting that was outside, and that's when we fired it up. We fired it up inside the hotel. And there's Malcolm holding another device. That's another device altogether. That unit right there is what they call a Vajra turbine. Picture a turbine engine about the size of a 5-gallon bucket that puts out 500 times more horsepower than any engine that we know of. It's pretty amazing. And there's no moving parts. It's pretty amazing technology. So anyway, that's what I was doing with that. And now, since that 2023, this thing's been back and forth from India, Australia, I think it was even in the UK, and it's getting millions and millions of views and a lot of interesting white paper is being written. But the beautiful thing about it, what's going on inside it, there's another individual, and I know Dr. Yu knows because he saw him do his demonstration there, Dr. Grenier. He showed the physics behind what's going on in it, and this thing proves a cold fusion and transmutation of materials. It's pretty wild stuff. Very, very wild stuff. So yeah.
Any questions for Stephen?
Huh?
I'm asking any questions, Brian?
I mean, when you start playing around with energy sources, and it's virtually, it's free for the most part.
Right.
Other people get
comes after you.
Yeah, other people get upset, and I don't want to be the guy pointing to the big purple elephant in the room.
And in black.
Yeah, I mean, anybody that has played around with anything futuristic like what Stephen you've been doing and proving, do you fear in any way, shape, or form of, I know a lot of people have gone magically missing? or
like the guy that invented the car that ran on water and then ended up drowned in his pool, that.
And I don't mean it. I'm not trying to be on the negative side. I love this stuff. I love physics. I love what we can do. But when money's involved and power, people come out and they take what is, not theirs.
Yeah, the interesting thing on this technology, and I'll say the name of the website is strikefoundation.earth. And everything there is disclosed. It's open information to anyone that wants to make it. So I think he did the right thing. He made it totally public, and he's actually on YouTube. They have a whole bunch of stuff on it. All you have to do is type in thunderstorm generator. You'll get all kinds of stuff on it. I'm actually videotaped extensively on howtube.com from that convention, talking how it works and, some of the problems we had with it. The interesting thing about the transmutation of materials, though, that's the big deal. It's just wild. The same technology, it's actually demonstrated or explained at the Strike Foundation's website. You can actually get plasma injection and bombard a copper plate and actually transmute it into gold, which is really an interesting thing. Yeah.
When you go to cold fusion, I mean, that reminds me of Val Kilmer in The Saint. That's the foundation of all the spy sickle movies is cold fusion, free energy, and that was what Tesla was about.
So Brian, this thing here, the whole you might say intent, because Malcolm's into he's like a the engineering has got to do with like oil and minerals and stuff like that. That's his background. And he came up with this idea. So because you look at India, where they make their energies mostly burning coal and oil, which is very toxic and stuff like that. You can take this unit and hook it up to those big, huge diesel generators, and you're getting not only your energy production, but you're completely drastically removing all the toxicity. And interesting about this, as the intake of the oxygen, you can add also destructive chemicals into this thing, and it converts those too. And this
What
can
does
be
it
applied.
convert them to? Something not destructive?
No, it just transmutates it into power. It takes toxic stuff and just turns it into plasma, and then you can burn it, which is really, really fascinating stuff. If you go to the Strike Foundation, you'll see the big, huge generators. I mean, these are, big kilowatt generators that run cities and stuff. And that's where the big application with this, but it can be done for refineries, jet engines. It can be applied to anything. It's pretty amazing.
Dr. Yu, what are your thoughts on this?
Oh, I'm sorry. I did not follow. I was trying to make sure I put another screen here, so I was setting up.
Okay.
Sorry about that. Yeah.
I do
That's
have
okay.
a question though, and that is, you showed us a donut shape a piece of stuff, and I'm looking on the website, and they're showing that as well. Is that related to what you're talking about?
Yes, because of the implosion of water and the process of it's doing it, it makes plasmoids, and the actual shape of a plasmoid is toroidal, which is very interesting.
Okay, so that's what that is.
Yes.
Okay, and then
it's a counterforce. It's space counterspace. It's turning the oxygen into that what you call fifth state of matter. And it becomes very flammable, and you can extrapolate that energy. It's really a fascinating technology.
Now,
and
and I'm looking at the donut, and you've got around the very outer edge, +1, +2, +3 on one side, a 0, and then a -1, -2, -3 on the other side. So this goes into that electromagnetic information that Dr. Yu was talking about. Is that correct?
Exactly.
And how does that play into it?
Well, interesting that you mentioned that, because this stuff does have a bipole to it, because the way a toroid is made, a toroid is actually a definition that it does have polarity because of the spin that's happening in the toroid itself, and how the actual spin or the rotation of what you would call it. We would call it mass. I call it vibration of taking nothing and moving it is causing physicalness, if you will. As it's rotating, it's causing just stuff. Anything moving is going to have a magnetic component to it, because it's the way matter is. Anything in real fast motion is going to be a very, very disturbing thing. A weird thing, you can get like those little toy compasses. You can even put a battery next to it, and the battery's got potential charge. It'll actually affect the needle of a compass. Just being.
Brian, do you want to weigh in on this, Brian Singh? Brian Singh?
Yeah. Well, basically, it's like a.
And we can't hear you.
You're really low.
Yeah.
Better now?
Yep.
Yes.
Okay, sorry. I got my baby daughter in the background here. It seems that this is a demonstration of sacred geometry. The circle is a flattened version into the 3D, the torus, the donut, but that spiraling and that fluxing. And then when you apply that whole implosion vortex mathematics and sacred geometry, and you apply it physically in the material by, say, combusting or burning hydrogen or injecting it in a certain way of oxygen to turn it into that plasma state, by utilizing these sacred geometry shapes, that's what seems to help achieve this plasma type state. And so when you go into people who are talking about like meditation, and they're visualizing a lot of these states, and the vortex math, as Dan Winters in our community does, it's it's specialty. We're basically seeing a manifestation of like what's above the mathematics, and then what's below, manifesting that mathematics in physical form to then transcend normal states of matter. Like, we're not normally getting to access the plasma state, but because we're using this toroidal geometry, and the sacred geometry, we're able to then access those states in the physical.
She thinks so too. Now we are going to be going to something that Dr. Yu, I think your presentation got removed from the room, but I'm just going to add the one that I have.
Oh, okay. Sure.
I'm not sure what happened to yours, but I heard a pop and then it went out. So we are going to be addressing the Yuan theory and the blunder of the 2025 Nobel Prize in Physics. I did want to bring in the discovery that, and we're probably going to separate this. So we'll have Stephen guide us in 1 week, and then Dr. Yu guide us in another week for just different principles in physics, so that people can start understanding this quantum confusion. So in here it says from quantum confusion to magnetic clarity and the quantum misinterpretation. Shall I go to the next slide?
Sure. This is a presentation I was presented to another organization in El Salvador. It's another organization. Okay.
Oh, wow.
So since we have a new, I just met the Brian Bolden. So I just want to give you a little bit of introduction about the Yuan theory. And I, based on the Yuan theory, and find the fundamental flaws in 2025 Nobel Prize award. So basically, Yuan theory, basically the whole universe made only by one particles. That's a magnetic particle. If you look at the picture on the right, top right, that's all. And I can prove none of other type of particles, say electron, proton, quarks, so these are single charge particles, can exist. I can prove they cannot exist in the universe, but that's a different type of topic. So today I just say, hey, started with Yuan theory discovery, the universe only made by one particle. Thank you. And
sorry.
Yes, you did a good job.
Okay, because I accidentally touched my other laptop, and it's like going wiggy on the next slide. So sorry about that. Let me just go back. Here we go.
You okay? Yeah, if you can get back, that's wonderful. So basically, if you go down next page.
Okay. Oh, so I was doing good.
Yes, you're doing good. You know, this page basically say, did you see the Yuan theory? That's the bigger circle. Yuan, that's basically the magnetic particles, magnet, dipolar magnet. It manifested all the mass, volume, charge, and all different forces. But this is too long, not for today. Okay, and many other people is already read my. So then we can jump to next page. Yeah.
Okay.
See if fundamental error. You go to another page. So this is the page I try to describe what's wrong with physics. Right now we have quantum mechanics, we have relativity, we have a classical mechanics, which has a problem too. So that's why triggered people discovery. Hey, we have to discover something more than classical Newtonian theory, and include the classical electrodynamics. So that's why we gave this called quantum mechanics and relativity. And so I try to explain what's wrong with physics, not only wrong in modern physics, but what's wrong in classical physics. And this is a page I try to say, hey, it started at 1784, when this French physicist, Charles Coulomb, developed a Coulomb law, says like charge repel, opposite charge attract. So this part of the law is correct. However, it implies the two different electric charge carried by two separate particles. That's where I consider that it's totally wrong. It's wrong. I call it a monocharge particle. So a particle can only carry one charge, single charge, electron, or carry a positive charge like a proton. I believe these kind of single charge particle cannot exist. But this is something we can discuss in another setting. Okay. Now, Penny, you can go down. Yeah, this is an experiment. I try to say, hey, why people say, hey, why do you say Coulomb's wrong? Why like charge not repel or opposite charge attract? And I said, that part is correct. Opposite charge attract, like charge repel. However, the problems with this electric charge, and where we come this one. So I point to one of the earliest discovery of electron. Electron considers a negative charge particle started by discovery by J.J. Thomson. And I said that this experiment J.J. Thomson did called the cathode ray tube experiment. The experiment is self-evident, however, interpretation is wrong. Yeah. So which part is wrong? So the whole experiment demonstrates that when you have two electrodes have a charge, have a voltage, you create the line. These lines are ionized or magnetized particle inside of a tube. This is a gas particle inside of a tube. So when you have a charge, you have a voltage difference, you ionize, which is equivalent to magnetize the air molecules in the tube. So that's what happens. The tube under voltage differential form a line of magnets. So all the particles becomes magnetic particles. That's called the charged particle. So that's why it can interact with magnets. So the problem is this is a magnetic event. So let me. Oh no. You do not have the video. Okay, it's a magnetic event. However, J.J. Thomson explained as a electrical event. He said, "Oh, we discover a negative charged electron." That's something. Since then, derailed entire physics. The physics is run off the wheel since that time. But this experiment was considered the greatest discovery at the end of the 19th century. It's on the turn of the 20th century. Okay, so now we can go further. Penny, yeah, okay. So such a kind of error, why such an error being accepted by everybody? It's a simple explanation. Looks like a very intuitive. Feels like, oh, we do have electron travel, emit from one electrodes, sliding to in other electrodes and go through the circuit. Seems like very intuitive, right? But that's totally wrong. What happens is that there is no particle emit from one electrode and fly to another electrode. What really happens is all the gas particles being ionized, which equivalent to being magnetized, become small magnets. So that's why they form a line of magnets. Then you use magnets. They use magnets to interact with the line, like a light line, and it interact either bending upward, if you reverse bending downward. So this is a fundamental mistake. So how people realize, and then another way is Nobel Prize. Canonized the conceptual error. Whenever you award you Nobel Prize, you believe this is absolutely correct. Is that right? And you look at I listed 9 people. I use ChatGPT to say, hey, how many people involved with this called a negative charged particle? Electron, positron, proton, quarks. You can list at least 9 people win Nobel Prize. Say, hey, if J.J. Thomson discovered a negative charged particle, then somebody else, hey, I discovered a neutral particle. And another one say, hey, I discovered a positive particle. And another one say, hey, based on negative positive, I discovered what an atomic model that's orbiting, that's called the orbital electron model. And some say, okay, so that's, and eventually, because of this error, we have a born of the quantum mechanics, which is a completely fundamentally fatal flaw. That's in several other videos I had, but today I'm gonna just say, then if you can go to next page, that's the 2025 Nobel Prize in Physics, award for 3 gentlemen. If you look at the John Clark, he's the key professors of this project. Of course, the majority work is did by the I believe that's a central one. That's John Clark's postdoctor. That gentleman from France, and the third, that's John Martinez. He was the PhD student under John Clark. So that's a group of people wrote a paper on the subject. So now I believe we do not have much time. So if you can jump to jump to different page, and I will call you. Okay, maybe let's stop it here. So
okay, we can always pick this up. You don't have to cram it all into one segment because you're on every other week.
Yes. Okay. So I just say, hey, so why this year award people discovery something about quantum mechanics? I said, hey, what's special of this year? And if you look at the first bullets, it says centennial means 100 years celebration of quantum mechanics. It's born of quantum mechanics year. So that's why I believe Nobel Committee think about quantum mechanics such a big part in our life. So this is reasonable. So basically, if you look at the pictures so that's the Schrödinger. He has a famous foundational Schrödinger equation formally defined as quantum mechanics first year, 1925 to 2025, so 100 years. And another things besides our 100 years celebration, another years is everybody try to come up with quantum computing, build quantum computer. That's a big part of the year. They said if we have a build a quantum computer, we can compress 10,000 years work in few minutes, in one day, okay, in 1 hour or something. So that's why everybody believe how this is such important. If that is true, it is remarkable. And another things about the quantum mechanics, even though quantum mechanics is born for 100 years, we have so many confusions in quantum mechanics. So if you look at bullet 3, called the conceptual correction needed. Because to be honest, all the people win Nobel Prize, right? And the founder of quantum mechanics, they don't believe anybody truly understands quantum mechanics because they don't even understand quantum mechanics. They just get a mathematical model or match some kind of experimental results. They know they don't understand, but they say, hey, if you think about it this way, hey, we can match results.
So it says in there, conceptual correction needed problem, quantum mechanics replace causally with probability solution. Physics must return to mechanism and structure, restoring physical realism for true progress. Why do you think that the Nobel Prize was awarded incorrectly? Are they not accepting any propositions that alter the stagnant propositions that they had accepted as true?
Very good questions. So now I believe we can go to the page. I don't know the page. If you can scroll down, so that's the paper. Yeah, keep going down, down. I will tell you the stop. Yeah. Yes.
Can I just take and put this into simple terms for myself?
Yes, of course.
Because what I'm seeing is that as they were discovering these things, they were dividing it up in separately, everything that, I found a negative, so that's a particle. I found a positive, so that's a particle. I found a piece that's neutron, so that's a particle. And in reality, they complicated it because in what you discovered was no matter how you split a magnet infinitely down, you always had a positive and negative. So it's really quite simple. It's just that one, right? Is that this is the ooon that you're talking about. And so when you simplify it, then some of these paradigms that don't work begin to be resolved. Is that what I'm hearing?
You nailed it. Oh my goodness. Your intelligence above. Exactly. I hope, the Brian Bolden, since you're here, basically, June Renee, he just explained my Yuan theory in the very fundamental term. It's better than I could explain. she basically say, hey, the Yuan theory says every single particle made by magnets, because magnets, if you can subdivide the magnets, you always get smaller magnets, right?
Yeah.
So and then another term she also mentioned about that. So if I say everything subdivided by magnets, and then all other material, all other particles, just like they discover some quantum effect, other particles. All other particles based on the Yuan theory, they're all made by magnetic particles, composite magnetic particles. So they are all magnetic particles. Right? Really?
Yes.
So that means the whole thing is very, very simple. The universe is actually very simple, just by one particle, made everything. And this quantum mechanics overcomplicated by, hey, we have a negative charged particle, we have a neutral particle, we have a positive charged particle. Now, how can you make atoms work? You have a negative, positive. You have to. You cannot let it stay still. Otherwise, the negative and the positive, that annihilation. That's a matter and atom will no longer exist, right? So how they do? So they said, oh, the negative and positive. So negative particle have to orbiting electron constantly at the nearest speed of light. Otherwise, it were not enough to hold them. So that's where complicated the entire physics, the entire real world. Renee, I answered lots of online questions.
Well, Dr. Wu, Dr. Yu,
yes,
Dr. Yu, is it kind of like the difference between we're thinking about an electron or a nucleus,
yes,
and then we're thinking about an electron going around the nucleus, but instead of visualizing the electron as like going super fast in whatever orbit it's going around the nucleus, instead what it's doing is it's zapping in and out, phase shifting out of our physical reality as we know it, and tunneling and basically warping back and forth. So there's a difference between going from A to B to C to D to E and just being able to jump from A to E to F to B to G and just keep jumping around. And so are you saying that the more contemporary, conventional rather, model of physics is more a conception of less quantum and it's still tied to this more, I don't know what you want to call it, Euclidean type of geometry?
Not quite, but you are close. If you listen to what Renee explained, everything built by just one particle magnet. And the magnet, but you have a different size, right? They're all made by magnets. Just your subdivided magnets are smaller. So Brian tried to explain. So based on your theory, what's the atom look like? Let me show you what an atom looks like. Atom, just like a magnetic particle, form a big ball, magnetic ball. It's when you form a ball, it is still a magnet. So that's
those
what
are all magnets, aren't they?
Yeah, that's I did use magnets. You're right.
Yeah, those are magnets.
They are magnets. Why I put this one so big here? I try to explain the difference between electron and the proton. So I can use this represent the proton, neutron too. If you look at the size of electron, if you can see the red one, just the same size as one of them. The current analysis say electron is basically say proton is 1,836 times of little electron. So that's why I made this electron as a small, made this one approximate what is try to say 2,000 magnets. Yeah, so that's what. But they are all magnets. It's not, but the current theory make it complicated. Electron has to be orbiting, so create I call the perpetual motion atom. So every single atom is a perpetual motion machine. You cannot, no physicists believe we have a perpetual motion machine, right? So that's why we say, hey, that's wrong. That's entire quantum mechanics built on the model, try to capture the electron's orbit. And your quantum mechanics means quantum jump means electron jump from one orbit to another orbit. The orbit is all surrounding a nucleus, right? Yeah, you got it. Yeah, nucleus.
So it's a never ending. I studied physics, by the way.
Never ending rotation.
Yeah,
Yes,
Brian,
exactly.
you got a lot of
It's-
smart people in here, Dr. Yu.
Yeah, it's not only a
It's
never
definitely-
ending. It's almost a never ending pursuit. It's always in motion and movement.
Always in
But what
motion.
changes is the magnetic field or energy in the size. So you could be +1, +2, 3, 4, depending on what it is and what it's doing. And that's why when quantum tunneling comes into play, it will actually go in and out of the different areas that it needs to quantumly and change its magnetic structure to adapt to said area. The problem we have in physics and why I stopped doing it is we have all these really smart people that get paid money through universities and studies and what they do, and they need to be the best and they need to be number one. So they'll all, it's like a legislative bill in Congress. They jump on a bill so they'd be known for something, but it doesn't necessarily mean what they're stating is fact. Whereas Dr. Yu is pointing out yuan theory, and discrediting. You can't just throw any in physics, whether it's string, quantum, whatever. You cannot throw anything out. Everything is part of the equation.
Right.
Even the stuff that falls off of the equation is still part of that equation because it's a balance. It's a balance in physics. And that's why, like, I'm looking at some of these things and I'm like, oh, I remember that. But it's really hard. And that's why the quantum computer, the way it works is it is beyond, it's faster than the speed of light. It's almost virtually instantaneous. It's almost as fast as speed of consciousness, which is faster than a speed of light. And that's how quickly it takes place. And we can't comprehend it. Brian, remember when we were talking about 2D, 3D, and if you do a drawing in 2D, someone in the 1D, like, or whatever, you do a 3D thing, 2D people can't see it in the right manner because they're not up at that level. It's the same thing. But unfortunately, some of these doctors, hey, God bless you, you spent all that money to go to school. They're proposing whatever, but Dr. Wu here is saying you're wrong. You're discrediting something that is a fundamental basis of this.
That discrediting thing happens a lot.
It does.
Oh wow, we have the smartest people on the panel. I was even want to ask Penny, invite some celebrity physicists. We have those around.
We do.
Okay. So now I can, since Brian explained it so clearly, so now I can tell, and Joanne, so you all know what it is, right? So now I can tell you what's wrong with this Nobel Prize. The Nobel Prize is called quantum tunneling, assuming, so we have two conducting material, right? We have gaps, use insulating gaps. The so-called quantum tunneling, assuming there's an electron can jump through the gaps, fly to the other side. That's called quantum tunneling. And under any classical physics, you have a resistance, you have a gaps, discontinuity. You have no way. You have electricity on this side and you have a current on the other side. But quantum mechanics tunneling, quantum mechanics means everything classical mechanics cannot explain, quantum mechanics can explain. Say, hey, under quantum probability equation, you always have some probabilities that can go through the barrier without regardless of any classical mechanics. You have to hold, you have something. So that's what a quantum principle.
Because basically classical mechanics simply sees the world as a vacuum, and proper quantum mechanics understands that because there's a field, now you have a medium to transmit across, and classical physics has never accounted for that.
You're right. Of course, the quantum's vacuum, quantum have a medium there. It's different than relativity medium. Okay, so I'm not going to talk about that. But I just want to emphasize now. So what's wrong? Because there is, in yuan theory, there is no orbiting electrons. Of course, there's electricity, have no particle traveling across anything, any barrier from here to here. Nothing exists. Electricity is only oscillation. So that's why we have an AC. Why electron travel at the speed, nearly speed of light, can change in direction to 120 times per second. Actually, what happens is atom just oscillating. When you're changing polarity, oscillating, but nothing traveling from this side to other side. So now you know what's the problem with quantum tunneling. Assuming you have an electron traveling from one side to another side, this is a fundamental error. Okay.
So, Dr. Wu, I got another question for you, because a part of what you're talking about requires friction, doesn't it? Because if you're going to magnify a nail, you have to do friction on it, and then you can get it magnetized when you do that. So this is where where you get that electricity, or you get the magnetic polarization, and so it's a vibration that causes that. But then you also have different materials. Some will conduct more than others.
Of course. Yeah.
And the resonance would then be the difference between a material that is highly magnetized and
that's
one
exactly.
that's
Yeah. Resonance is different. Yeah. So if you have say US uses 60 hertz, so 60 hertz frequency, right? So that's optimized for the oscillation with smaller resonance, right? But some places they use 50 hertz in other countries, right? US 60 hertz. It's all based on what's the resonance frequency is the best for the specific material. If you use a different material, you will see conductivity will be different because the resonance frequency slide off.
See, that makes sense. Oh, that makes sense with your theory with the Uon, but it doesn't make sense with the atom to me. The atom doesn't make sense to me, but the Uon does, for the friction and how things come together and hold together, and why you have different materials. That makes sense.
Yeah, it's also, we have to do some experiments off planet, because our planet made up of the materials and atoms and molecules it's made of. Once you get from here out to outer space, there are other variables that may, change materials that were once not good on Earth to better materials out there. It gets really complex. That's why they have the collider, so they can operate in almost a non-oxygen and space replicated version of what they're trying to do. But we need to build on the moon or another planet, more of these labs to do better testing, and you'll be surprised what you discover. But
like Musk says, on Mars.
I mean, yeah, you can do it on Mars. I mean, every planet has their own materials that could be very good for future physics-based products or outcomes. But the problem is, this is like these communities where people just stand their ground. Like, I think this is this, and I think it's this. And it's almost like a little bit of it's an intellectual battle going on. And sometimes people are so arrogant that, they get these awards, but they shouldn't have gotten them.
That's exactly. Oh my goodness! So I'm so happy. I thought that this is going to take a long time to explain, and you guys already understand. So I wanted to answer June Renee's one question. She mentioned about the friction. So where friction comes from? Okay, in current theory, electron traveling inside of a solid wire, right? Solid, you bumping through, you make collection and create a local vibration, create a heat, go through them. So that's the friction called consuming energy. But in this model, since there's no particles traveling, so where comes the friction, right? That's so-called friction. We are talking about the resistance. So resistance is one thing. Resistance comes from if you exactly hit, if you input force frequency, excitation frequency, just like the motor rotating, right? That frequency, that's excitation frequency, exactly match the materials atoms resonance frequency. If you're not matching, you're consuming. You have some chaotic motion, right? You create a heat, you're consuming some energy. So that's part of the resistance. But another part of a resistance, nobody else knows this, and your theory can explain. In order to make atoms oscillating, you need to create called angular momentum, provide force to oscillate, right? You can make some oscillator. You have spread force, the back force. So the matter, so the oscillation that's called instead of the mass is called the angular momentum. Angular moment, the mass make the angular momentum. So that consuming some part of energy. So that's where comes resistance. It's not like a friction bumping along the way. It's about in order to make some oscillating, you consume energy, and also oscillating at the resonant frequency, you consuming you have the least resistance. But if a slightly deviate resonance, basically that different material will give you different resistance.
So I have another question, and
Go
that
ahead.
is, assuming that the muons are round and they're magnetic to where it's a north and south pole, and one is turning, it's causing the other to turn, right? And this would make the electricity or whatever travel. And if you can reduce the friction and increase the speed, then you would get. That's what we're going for when you're looking for quantum, isn't it? I'm just asking.
Oh,
or have I gotten off track?
Okay, I understand your explanation about how electricity propagates. You know, we have a motor, right? We have a generator. Generator electricity is always a relative motion between coil and the magnet, right? The cycle.
Right.
So that means this rotating motion created a cycle, and so this is a local event. Right, only coil inside of the magnetic, the what is called a generator inside the general magnet. How could they propagate? That's a magnetic flow because all the particles connected, magnetic connected. If you rotate one, I don't know if you can see, the other one is gonna pulling up because of the magnetic alignment. So that's why. If you rotate one, the other one will rotate with you, and the way propagate through the wire.
That's what I was.
Yes, you got it. And what's the final questions you about this one?
Well, I was wondering if you reduce the friction, but you can get the rotation going.
Then okay.
Would it go faster? As you reduce the friction, but you can get the rotation of the magnet going in the highly magnetized, would that increase the speed of the electricity?
You sometimes you rotate too fast. There's a problem. It will burn. It will.
Mustang Sally, slow that Mustang down.
Force too high. You break them. When you break them, that's where the material burned.
Oh,
you get an event horizon with anything in excess, and then you get the positive versus everything. See, the whole thing in physics is if you have positive, you have negative. If you go up positive too much, then the negative increases by that much. It gets really. This is why it's so complex for people to wrap their minds around. But if you gotta, sometimes you have to put all that old physics stuff to the rear and start with new theories based on new concepts as hypothesis, test them, and then you'll realize that some of the stuff we've been doing, even though Einstein was here and here's Tesla's, he's going, and we're paralleling partially, but what Tesla was bringing to the equation is far greater than Einstein would ever be.
Tesla got screwed over by Einstein. And speaking of awards, Tesla was like across the street drinking at a bar when Einstein said, "Hey, we're going to give you, the Einstein Award for all the tech that I stole from you." And he's just like, "I don't think so. I'm not taking that." And he probably took a couple more shots and said, "All right, just give me the $200 I need to pay my rent." But that's the way that it goes, unfortunately, in all areas of life. The spurless ones have been winning.
You get into physics, and when you get into certain sciences, it's not about this; it's about continuing the study. And people, that is more valuable than money, because money just gets you. It's almost like a drug, in a weird way, where you get your fix by discovering more and more and more and more and more. That is more important than, like with Steven and the new engine and the new system, there's a lot of money to be made there. But by giving it away free, you kind of give yourself a get out of like someone hurting me for free card, and the world benefits. It's all about the knowledge and less about the compensation from it. So I give everybody credit. I got out of that.
We have come to the end of another wonderful Agent X11, and this is Dr. U's Universe with Brian Singh Presents and Steven Sanchez. And I thank you all for joining us. Brian Bowden, I guess you're a regular now, so I'm going to have to put you on the promo. And Joan Renee. Yes, Brian. And so I thank you all for joining us. And tell everyone where you can be found. Brian Singh, you go first.
Yeah, Full Disclosure Network, Full Disclosure.network or fulldisclosure.live. And also you can find me on Facebook by plugging in my name, Brian Sang and Solar Bee. And I'm also here every Thursday.
And Dr. Weeping, where can they find you?
Okay, I do not have a personal website, but you can find me from a Twitter account, or now called X platform. Use at real Dr. U. So at real REALDRYU at real Dr. U.
Well, you are going to have your own TV show, so there's that. Steven, it's called Dr. U's Universe. Steven Sanchez, where can people find you? How can they get in touch with you?
Okay, you can get me through my email. It's the number 1 and one word, goldentiger@gmail.com.
Because you're number 1. And Brian Bowden, where can people find you?
Well, Third Eye Live every Wednesday at my YouTube at symbol Brian with a Y, Bowden, one word. 8 p.m. to 10 p.m. Eastern. I'm on Awaken Nation. Apparently, I'm now on Agent X11. So, and I'm looking. Yeah, I'm doing conferences and doing some presentations there. But can't thank you enough, and Joan enough, as well as Steven, Dr. U, and Brian Solarby. Great show and great group of people. Great discussion.
Yes. And Joan Renee, where can people find you?
You can find me on Agent X11, The Awake Nation Tuesdays and Thursdays, Trauma Triage on Wednesdays, and you can also find me on X, Joan Renee 27.
And you can find me on X under Shepherd Out, because apparently I was in, but now I'm out. Maybe not. And you can also find me on the Awake Nation Monday through Friday. I do the Awake Nation News with my co-host Joan Renee and several others, Skip Press and Jen Marie. And you can find us doing the news on the David Zubik channel for Awake Nation. And that is Monday through Friday. That's 7 to 8 a.m. Eastern time. And then also we do the Awake Nation with the fantabulous David Zubik on the David Zubik channel on Rumble. And you can find that at 8 to 10. So our entire experience every day is from 7 to 10 Eastern time. So please join us on the David Zubik channel, and please like, share, and subscribe. Please join the Agent X11 channel and just jet this out everywhere, because that's how, we spread the goodwill throughout humanity. No one's making money off of what we're doing here. We're doing it because this information needs to get out there. So thank you again for joining us, and we're out of time. So we are out of here. Shepherd out.
Bowden out.
Renee out.
Solar Bee out.
Dr. U out.
Steven out.
Yes.
Goodbye for today from Agent X11, Hollywood Dark Journalist. We post new episodes daily. Check out our true crime episodes Wednesdays and Fridays. Don't forget to watch our main show, David Zubrick's Awake Nation, on the David Zubrick channel on Rumble, live Monday through Friday, 7 a.m. to 10 a.m. Eastern.